Okay, hello everyone. Let's go ahead and take a look at combinations. I'm hoping that all of you recognize combinations. Just take a look here. Hopefully this notation that we have here is very recognizable from the binomial expansion that we used. And so for this time when we come around and take a look at combinations, hopefully you'll have a deeper understanding of why it is this, okay, and how it relates to combinatorics in general. Now let's go ahead and juxtapose the two because I think it's going to be very helpful for us to realize the differences. Permutations again deal with arrangements of n objects taken R at a time. Now we're going to say that order matters here, and of course if you go ahead and you think of any arrangement, even if you have the same three things, if they're arranged in a different order, then of course the permutation is different. Now, combinations, on the other hand, deal with a selection of n from n objects taken R at a time without regard to the order. So the order doesn't matter when it comes to combinations. Now, let's take a look at this. If we talk about the question that is asked for permutations, we're talking about arrangements. If you have three things and you arrange them in a different order, then of course the permutation is different. But if you talk about the combination, so let's just say you have three things and you selected these three things, then regardless of the way that you go ahead and arrange them, the selection is still the same because you still have these three objects. So we have to keep that very separate, that line very clear, in that with the permutations you're dealing with arrangements, and then with the combination you're dealing with selections or choose, okay? So remember that what we do then is that when we come to combinations, again we're dealing with selection and therefore we're using the choose function. So we said that n choose R is the number of combinations on n distinct or different symbols taken R at a time. And this is what we come out with, is we come up with the n choose R, and we use this shorthand. Okay, before we went ahead and just put it into the calculator, but what we're going to come out and what we're going to notice is that what it actually is, it's n factorial divided by r factorial times by n minus r factorial. Now I'm going to relate it to the permutation this way, and hopefully that will give us a better understanding as to why combinations are calculated as such. Now let's go ahead and go back to permutations though first. Let's go ahead and take a look at our math example. Remember we said we had the letters M, A, T, and H, 4 letters. And let's say that we're going to choose 2 of those letters and look for the total amount of permutations that we can actually come out with. Now, we know that 4 permute 2 is going to be equal to 4 factorial divided by 2 factorial, and therefore that's 3 times 2, which is 12. Now what I've done here is I've gone ahead and listed all of the different particular arrangements that are possible using 2 letters from the word math. Okay, and then again here is our formula for the permutations. Okay, now let's go ahead and take a look at what we have here for choose. Now with choose, of course, what we're going to have is we're going to have the number of permutations that you have divided by r factorial. Now why is that? Let's say for example here again are all the different arrangements. Okay. The thing that we have to do though is that when we take a look at these arrangements, NA or AM doesn't make a difference because you selected those 2 letters as your choice or your selection. So what that means then is that these 2 are considered the same when we're talking about choosing. These 2 of course are also considered the same because they're composed of the same letters. So that one is the same, that one's the same. Let's see, what else? This one here is the same with this one here. So let's go around that way. This one here is exactly the same as that one there. The TH, and this one here is the same. And this one here is the same as this one. So what we have then actually is we have half as many choices because when it comes to the selection, there are only 6 possible different pairs that we can choose. We can choose A and M, any combination of A and M, any combination of MT, any combination of MH, any combination of AT, any combination of AH, and any combination of HT. Okay, so what we can do is we can just go ahead and say then that the choose, if you take 4, choose 2, then you take a look at all the different arrangements that are possible, which is 12, but then you have to divide it by 2 factorial, or 2, because those are the total number of repeated combinations that you have. And therefore you come up with 6. Now, we could have gone ahead and just calculated it straight from here. It would have given us exactly the same value. Okay, so let's kind of wrap this up again and take a look at this from a bird's eye view. Permutations and combinations are going to be different in the sense that, for one, permutations deal with an arrangement where order matters. Combinations, you're dealing with selection and therefore you're choosing. Now, if we wanted to go ahead and take a look at the choose function, the choose function is the same thing as the permutation of n, the n permute r divided by r factorial. So what you're going to always come out with then is that the choose is always going to be a smaller number than the number of arrangements that you have, okay, given the same context. Okay, so there you go. That's what we're going to take a look at next when it comes to our last principle for combinatorics, which is combinations. We'll go ahead and take a look at some of those problems more in depth in class the next time that we meet. Okay, so we'll see you then, and hopefully if you have any questions, make sure to bring them to class. Bye-bye.